In this presentation, we will learn how to insert a new node at the beginning of the circular singly linked list. So let's get started. Let us suppose this is the initial state of the linked list, and that too a circular singly linked list, and our target is to add this new node at the beginning of this list. Currently you can see that there is just one node in this list, right? Our target is to add this new node at the beginning of this list, that is in front of this node. Please note that the tail pointer is the pointer to the last node of the linked list. Here you can see we have a tail pointer instead of head pointer, because this is the pointer to the last node of the linked list. We are keeping a tail pointer instead of head pointer in circular linked list. But why? Why we are keeping a tail pointer instead of head pointer? Imagine a circular linked list with 3 nodes. Imagine this is the circular linked list with 3 nodes, and here this node is pointing to the first node. Let's say we have a head pointer pointing to the first node of the linked list. Our target is to add a new node at the beginning of the list. Our target is to add this node at the beginning of this list. Okay. For this, we need the address of the last node of the list. Now, if we want to add this node at the beginning of the list, we need the address of the last node. There must be some pointer pointing to this node, right? So that we can update the next part of this node so that it can point to this node. That is this node. Okay. Here we have to update this address so that this node can point to this node after adding this node at the beginning of the list. That is why it is important to keep a pointer over here, right? Because we have to update the link part of the last node so that it can point to the new node. Obviously, I told you already, we have to update the link part of this node. That is why there must be a pointer pointing to this node. In order to take the address of the last node, we have to traverse the whole list. Let me tell you, it is important to traverse the list in order to take the address of the last node. For this, we have to move our pointer towards right. Similarly, if we want to add a new node at the end of the list, then also the whole list has to be traversed. There is no doubt about it. Thus, if we keep a pointer to the last node in the circular linked list, then there is no need to traverse the list in order to perform both the operations. And you can always reach the first node from the last node as well, right? So there is no problem. Thus, we can keep a pointer to the last node instead of the first node because it eliminates the need of traversing the list, right? So, instead of a head pointer, we can have a tail pointer, which must point to the last node of the list. You can see over here, I changed the head pointer to the tail pointer, and currently it is pointing to the last node of the list. Now you can easily add a new node at the beginning as well as at the end of the list without traversing the list. Okay. That is why we are keeping a tail pointer instead of head pointer in circular linked list. Okay. So that is why we are keeping this tail pointer instead of a head pointer. New p next is equal to tail next will update the next part of this node so that it can point to this node. Please note here we have tail next instead of tail. Although there is just one node in this list, instead of tail next you can also put tail over here. But please remember that this is just one instance of a circular linked list. We could have a linked list of 3 nodes or 4 nodes or 100 nodes. In that case, obviously we always need the address of the first node of the linked list so that the new node which we want to add at the beginning must point to that node, right? For this purpose, we are putting here tail next because we are considering the general case. We are not just writing the code for this particular instance, right? Here you can see after this step, this particular node is now pointing to this node. After this, we just have to update the next part of this node so that it can point to this node. And that's it. This is all what we need. A new node has been added at the beginning of this list. You can understand that the time complexity of this program is just constant. We just need these 2 lines of code, and that's it. Now let me just show the complete code in code blocks. This is the complete code you can see over here. We have a struct node and we have an add to empty function. This is similar to circular singly function which we have seen in the first lecture. And this helps us in creating the first node of the linked list. And here is the add at big function which will add the data at the beginning of the linked list. The same code which we have seen. This will take constant time. We have a separate print function for printing all the elements of the list. And this is the main function. Here we are calling add to empty function first in order to create the node of the linked list. And we are also calling add at beg function after that so that we would be able to add a new node at the beginning of the list. And then we are calling print function for printing all the elements of the list. Let's just execute this code. You can see over here the output is 3445, because here you can see that first this function is called. Okay, this will create a new node and the data of this node is 45. After this function will be called, which will add a new node at the beginning of this particular node, which means 34 is added before 45. Thus the output is 34 and 45, right? Okay friends, this is it for now. Thank you for watching this presentation.